Okay. So now we'll try to find out inverse using the other way. Other way, as I said, using adjoint method. Okay. So mainly for adjoint method, as the name says, you have to find it, of course, adjoint. But before that, okay, before that, you have to find out minors. Okay. And then cofactors. Okay. So what are these minors and what are the cofactors? Minors are nothing but, suppose if you have a order 2 ka matrix. Okay. You have 4 elements, 1, 2, 3, 4. We will find out minors for each and every element. For each and every element, suppose we're doing it for one first. वन जो कॉलम में लाई करता है और जो कॉलम में रो में लाई करता है, just kind of ignore that row and column. Okay, so exactly opposite the number comes, that is called as the minor. Okay, so minor of the matrix is nothing but that is the determinant. Okay, right now since we have just a 2 by 2, so हमको उसका opposite वाला element मिलता है, that is the minor. Likewise अगर 2 है, 2 lies in this row and this column, so we're going to hide this thing. What remains, 2 का minor is 3. Likewise for 3, 3 जो रो दो कॉलम में लाई करता है उसका आंसर is 2. Okay, since it is a 2 cross 2, it's much easier to find out. When you'll have a minor for a order 3. Okay, order 3 के लिए, suppose if you have something like this, 1 2 3 4 5 6 7 8 9. Suppose you're going to find it for 1, hide that row and hide that column. The remaining determinant will be the minor of that first element. We'll do that in much detail, but right now you just should know what are minors and what are cofactors. जो भी element का we're going to find out minors, that row and that column should be hidden or should be ignored, and then whatever remains, uska determinant is the actual minor. Okay, so now finding out minor, it is noted using capital M, and of course the positions. If it lies in the, जैसे हम लोग aij लिखते हैं, a11 for the element, that is the denotion of element of the first row and first column. Likewise minor of first row first column will be n12 n11, so on and so forth. Now the next thing is finding cofactors. So cofactors में the cofactors ka formula we can denote it using aij, capital. Okay, initially we did small aij for the elements, right? So now it will be capital Aij for cofactors, and the formula for finding out cofactors is raised to minus 1 raised to I plus j mij, where m is nothing but minus. Okay, so cofactor ka formula, it is denoted using capital Aij. Ij is that row number and the column number respectively, and then that factors can be found. And now adjoint. Okay, as the name says, it's adjoint method, so you should know what is adjoint. So adjoint of a matrix is nothing but that cofactors ka whatever you get, uska transpose. So that matrix is your adjoint matrix. Transpose of the cofactor matrix. Okay. Now inverse ke liye, like how we like last time I said, we did it using row and column transformation. So then inverse using adjoint method ke liye, you have to follow one formula. Okay, this is the formula for finding out inverse of a matrix using adjoint method. So A inverse is nothing but 1 upon determinant A adjoint A. Here also the same rule applies. The inverse can only be found out if the determinant value is not equal to 0, so on and so forth. Alright. So let's find out. First, we're not finding out inverse. Let us first go through cofactors first. So the very first question is find cofactors of the matrix A, 2, -1, 4, and 7. So you have to find out cofactors of this matrix. So as I said, cofactors, this is the formula. But for finding out cofactors, we of course need minors first. So we'll find out minors. So let us first make it very simple. We'll denote each and every element first. Small a11 is the first element, first row ka jo element, that's 2. First row, second column, the element a1, 2 is equal to 4. Second row, first column, A21, that's minus 1. A22, second row, second column, that is equal to 7. Alright. Now coming to minus, as I said, minus of the first element. So this is the first element. A11 ka minor will be denoted using M11. How did I tell you you're going to find out minus? That row and that column in which the element lies, just cover it and whatever remains at your minor. So 2 ko cover karne ke baad it's 7. M12 for the first row, second column ka element. When we hide this, we get the minus minus 1. So in short, when you have order 2, it's nothing but uska ulta wala element. That's your minor. So M21. Second row, first column, this element will be hidden and then the remaining one is your answer. M22, this row, this column, and the answer is 2. Okay. Now coming to cofactor matrix. Cofactor of the first element, as I said, cofactor ka formula Aij is minus 1 raised to I plus j into Mij. A11 will be minus 1 raised to I plus j, correct? So that's 1 plus 1 into M11. This is nothing but minus 1 raised to 1 plus 1 is 2. M11 ka value is 7. So this is equal to minus 1 raised to, that's 1 and then plus. So A11 ka answer is 1. A12 is minus 1 raised to 1 plus 2 M12. So this is minus 1 raised to 1 plus 2 is, so whenever you have this type of power, right, इन दोनों को add होता है. So 1 1 है, so that is even, so it will be 1. 1 2 है, add करने के बाद you get 3. So then the answer will be ulta of the minor. So minor M12, that's minus 1. So this is minus 1 cube is minus 1 is minus 1. This is minus 1 into minus 1, that's plus 1. Likewise, A21, correct? A21 will be minus 1 raised to 2 plus 1. 2 plus 1 is 3. So the answer is going to be negative. So जो भी तुम्हारा minor था, उसका negative answer आएगा. So minus 2. So this is minus 1 raised to 3 into M21 is 4. So this becomes A21 becomes minus 1 into 4, that is minus 4. Okay, so this is just like shortcut. This is just probably because you're doing it for the first time, you may find it difficult, but once you try and practice, it will be very easy. यही सिर्फ add करना होता है 1 plus 1, so it's 2. So the answer of the minor and the cofactor will be exactly the same. Here it is see 1 plus 2, so it is 3. So it will be negative power. मतलब minor का जो है उसका opposite will be cofactor. Same number, sign will be ulta. Now for A22, 2 plus 2 is 4. So we know that the minor answer is not going to change. But anyways, we'll write it. This becomes minus 1 raised to 2 plus 2 is 4. M22. That's a M22 is 2. This becomes 1 into 2, 2. Okay. So these are the cofactors. Let us just list the cofactors. A11 is 7, 1, minus 4, 2, correct? 7, 1, minus 4, 2. Okay. So this is nothing but cofactors, but you should always find out cofactor matrix. As I said, adjoint is nothing but transpose of the cofactor matrix. Anyways, right now we're not finding adjoint or inverse, but it's just that you can put that cofactor matrix properly. So when you just compare the kind of question, no, original question that you got, 2 4 minus 1 7 था. This you have got 7 1 minus 2 4. So it's exactly ulta. इन दोनों का positions change हुआ है, right? So that cofactor is like it's not the different, but just the position change हुआ है. So that's like a shortcut. In case if you have an MCQ or something like that, you don't have to solve and sit and solve. Of course, when it is a 2 mark 3 mark question, you have to solve with each and every step. Now let us find out. Now we have done cofactor. Now let us find out adjoint. Okay, adjoint, as I said, it's nothing but this thing. So anyways, transpose of the cofactor matrix. Okay, so instead of finding out adjoint, let's find out inverse only now. Find A inverse using adjoint method. Okay, A inverse using adjoint method. So A inverse using adjoint method, where A is equal to 2 minus 2, 4 and 3. This is the question. 2 minus 2, 4 and 3. First thing is to find out determinant. So we are finding out determinant. So that is nothing but 2 3s are 6 minus 4 minus 8. So that becomes 6 plus 4, 14. 18, 14, that's not equal to 0. So A inverse exists. Okay. So now our job is to find out minors. I'm quickly going to find out minors. The first one, the minor is nothing but 3. The second 1, 9 is nothing but 4, m2 1 is co-opposite is minus 2, m2 2 is co-opposite is 2. Okay, now the cofactors we're going to find out. Cofactors a11 minus 1 raised to, I said 1 plus 1 that is equal to 2, so that answer will not change. You can of course write it, but this is just a shortcut way. 1 plus 2 is equal to 3, odd power, so the answer will change. 2 1, that is 2 plus 1 that is equal to 3. 3 है odd है, so the answer का sign will change. A2 2, 2 plus 2 is equal to 4, so answer का sign will not equal to change. So minor and cofactor will have same sign. This you can get in fill up or something like that also. When will that sign change, or when it will not change, when the power is odd or even, something like that. Okay, so we'll write the cofactor matrix. Cofactor matrix is something like this: 3 minus 4, 2 and 2. Now, as I said, adjoint matrix is nothing but transpose of the cofactor matrix. Transpose means rows become columns and columns become rows. So 3 minus 4 जो row में लिखा है वो I'll make it as column. So this is your adjoint matrix, which is equal to transpose of the cofactor matrix. Okay. So now we're finding out inverse. Inverse ka formula as I already given you, as I mentioned it above. That is nothing but 1 upon determinant A. What is the value of determinant A? That is equal to 14, right? So that is nothing but equal to 1 by 14 adjoint A. Adjoint A is 3 minus 4, 2 and 2. This is nothing but A inverse using adjoint method. We'll do finding inverse using adjoint method for order 3 matrix in the next class. But that is also similar, but it involves thoda sa extra calculation, that's it. And then I think it's easy. So it's important that you understand how to find out inverse, because after this I think you have its applications where equations are given and then you have to find out values or its inverse. So that becomes sort of difficult. So you have to go through this properly first. So we'll continue in the next class.